So why in 2026 do we still not have one single commercial thorium plant on the planet? To answer that, let's go back to Oak Ridge, Tennessee in the 1960s, and to Alvin Weinberg, who ran the lab there for 18 years. There he was convinced that fuel rods sitting in pressurized water were the wrong design entirely. In 1965, his team switched on the molten salt reactor experiment, which had no fuel rods at all. The uranium was dissolved straight into molten fluoride salt and pumped around the core like very hot water. It became the first reactor in history to run on uranium-233, the fuel you make from thorium, and ran until December 1969. This reactor never actually bred thorium, it just proved the engineering. The machine that was supposed to start breeding thorium at scale was the next step, which never actually happened. The Atomic Energy Commission backed a rival design, and in 1973 Weinberg was pushed out of his own laboratory for refusing to stop arguing for his design. But thorium has had its way of fighting for its place, mainly because it's about 3 times more abundant than uranium. And even then, the uranium that we're after, uranium-235, only makes up about 0.7% of what we mine. Compared to the specific isotope that we burn, thorium is hundreds of times more available. Meanwhile, the OECD's Red Book puts identified uranium resources at a little over 135 years of availability at today's consumption rate, and that could decrease drastically once data centers start bidding for their own reactors. Now the problem is that thorium is fertile rather than fissile. The difference is that fissile materials can directly sustain a nuclear chain reaction by splitting when being hit by slow neutrons. Fertile materials, on the other hand, cannot split easily on their own, but they turn into fissile materials after absorbing neutrons inside a reactor. So you hit thorium-232 with a neutron and it will not split, just absorb the neutron and become thorium-233, which has a half-life of about 22 minutes. So it decays into protactinium-233, which takes another 27 days or so to become uranium-233. That is a breeder reactor.